All right, so now that we know how to add and subtract our rational expressions that have like denominators, we're now going to talk about how to do it when we have unlike denominators. So just like when we were working with fractions, when you were adding and subtracting fractions, we had to find a common denominator. And in order to find the common denominator, we always looked for the LCM. Now, if you don't remember what LCM stands for least common multiple. So if our denominators are not the same, the first thing we're going to do is find the least common multiple, or the LCM, of the two denominators. So let's just practice finding the LCM between two different uh, monomials right now. So let's say I had the monomial 6x and the monomial 4x to the third. And I wanted to find the LCM between these two polynomials, or between these two monomials. So one of the easiest ways to do this is to first find the prime factorization of each of our monomials. So in order to do that, I'm going to start with the 6x. Now what I mean by the prime factorization for our 6x is what can I break 6x up into? What are the prime numbers that I can multiply together to get 6x? So I'm going to start with the coefficient part of it, the 6. And I'm going to say, well, what are the prime numbers that break up into 6? If you can remember to make your factor tree here, 6 has multiples of 2 and 3. And those are the only ones, because 2 is a prime number and 3 is a prime number. So that right there is the prime factorization of 6. Now I have to remember I'm doing 6x, so I also have to add in an x here. Or multiply, I should say. So the prime factorization of 6x is 2 times 3 times x. I'm going to do the same thing with the 4x to the third. So I know 4 will break up into 2 times 2. And x to the third is just x times x times x. So you're just going to write out what your variable to the exponent is. All right? Well, now what I'm going to do is I'm going to use each of those prime factors and take the greatest amount of numbers of times it appears in either of the factorizations. So what I mean by that is in the 6x, I see 2. Right? 2 is a part of the prime factorization. But in the 4x to the third, I see 2 2's. So what I want to do is I want to take the greater number of 2's. I'm going to take the 2 2's, and I'm going to put those into my LCM. So I'm going to have 2 times 2 as part of my LCM. And again, like I said, I'm taking the 2 2's because 2 2's is greater than 1 2. I'm always going to take the greater amount. So I'm taking the 2 2's rather than the 1 2. Then I'm going to move on to the next number. I'm going to look at the 3 here. So in the 6x, we have a 3. We have 1 3. And in the 4x to the third, I have no 3's. So obviously, which one is more? The 1 3 is more. So I'm going to put times 3 into my LCM. Then I'm going to look at the variables. In the 6x, I have 1x. In 4x to the third, I have 3x's. Obviously, 3x's are greater than 1x, so I'm going to put my 3x's into the LCM. Now that I have gone through every single part, every variable, every coefficient that we saw within the LCMs of my two numbers, now I'm just going to take everything that I put into this LCM and I'm going to multiply it together. 2 times 2 is 4, times 3 is 12, x times x times x is x to the third. So the LCM of 6x and 4x to the third would be 12x to the third. So that's how we find our LCMs. Now, let's say we didn't want to find the LCM of a monomial. Let's say it was the LCM of a polynomial. something along the lines of, we want to find the LCM of n squared plus 5n plus 4 and n plus 1 squared. So let's say we want to find this the LCM between these two polynomials. So when we have polynomials, it's a little bit different. We don't take, each coefficient and break it up and each variable like we did for the monomials. We'll only do this if we're finding the LCM of monomials. If it's a polynomial, we are still going to break it up into its factors. But we have to remember, to break a polynomial into its factors means to factor it. So I'm going to take each of my polynomials, and I am going to factor them. So I'm going to take the n squared plus 5n plus 4, and I'm going to factor that, meaning, again, two numbers that multiply to get 4 and add to get 5, that's going to be 4 times 1. So this is going to factor to be n plus 4, n plus 1. Then I'm going to do the same thing with the n plus 1 squared. I'm going to factor that out. So n plus 1 squared. Now, there's really not much to factor, but what I will do is I'll just write it out as n plus 1 times n plus 1. Okay? So when you have something squared or cubed or whatever, just write it out as each of its factors. So meaning 1n plus 1, 2n plus 1. So that's what squared means. You're multiplying it by itself 2 times. Okay, so now I'm going to do the same thing as I had done previously with the monomials. Just now, instead of looking at single digits and variables, I'm going to look at factors. So I'm going to start with the n plus 4 in the first factor. And I'm going to say, okay, I only see one n plus 4 here. I see no n plus 4s here. So which one has the most n plus 4s? Well, that's obviously the top one. I'm going to take 1 n plus 4, and that's going to go into my LCM. Then I'm going to do the same thing. I'm going to look at the next one. I see 1 n plus 1 in the first factor. I see 2 n plus 1s in the second one. Well, again, like we did in this one, we took the one that had the greatest amount. I'm going to take the one that has the greatest amount of n plus 1s, which is the second one, because it has 2 n plus 1s. And I'm going to put them both in my LCM. So that would mean that the LCM between these two polynomials will be n plus 4, n plus 1, n plus 1. Or you could always rewrite this as n plus 1 squared, n plus 4. It really doesn't matter which way you write it. Both of them are exactly the same. All right, so I've put two problems here up on the blackboard, and I'd like you to try them on your own. Pause the video, take about 5 minutes. I want you to find the LCM between the two terms that I have here, the 8m squared t and 12m squared t to the third. And then I want you to find the LCM between these two, x squared minus 2x minus 8, and x squared minus 5x minus 14. So like I said, pause the video, take 5 minutes, and then unpause it and see if we get the correct answer. Okay, so hopefully these are the two answers that you got. For the first one, 8 can be broken up into 4 times 2. But 4 is not a prime number, so we have to break that back up into 2 times 2. So you have 2 times 2 times 2. M squared, you just write as m times n, and then obviously t is just t. 12 can be broken up into 4 times 3. 4 can again be broken up into 2 times 2, so it's really 2 times 2 times 3. M squared is m times n. T to the third is t times t times t. Then we go on and we look for which ones has the most of a specific number or variable. Because these are monomials, we can do it that way. So we look at 2's. The first one has 3 2's. Remember, we're not worried about the 4 because we broke the 4 up into 2 times 2. So we're not looking at that 4. So we have 3 2's here. Here we only have 2 2's. Obviously, 3 2's is more than 2 2's, so I'm taking the 3 2's and putting them first into the LCM. Now we go on to the n's. I see 2m's here, and I see 2m's here. So we didn't really talk about this, but if they have the exact same amount, it doesn't matter which one you choose from. I could pick these two m's or I could pick these two m's. Doesn't matter. Two m's will go into the LCM. Then I go to the t's. I have one t here. I have three t's here. Obviously, three t's are more than one. I'll put the three t's into my LCM, and then I'll multiply them all together. 2 times 2 is 4, times 2 is 8, m times m is m squared, t times t times t, t to the third. So my LCM for the first one will be 8 m squared t to the third. For the second one, because they're polynomials, we have to factor them. X squared minus 2x minus 8, two numbers that multiply to get negative 8 and add to get negative 2 are negative 4 and positive 2. So it's going to be x plus 4, x minus 4, x plus 2. For the bottom one, two numbers that multiply to get negative 14 and add to get negative 5 will be negative 7 and positive 2. So it's x minus 7, x plus 2. Then I move on to doing the same thing I did here. I look at the first factor, x minus 4. There's only one x minus 4 here, but there's none here. 1 is obviously the most, so I'll put that in my LCM. Then I move on to the x plus 2. I see 1x plus 2 here. I see 1x plus 2 here. Just like the m's we had in this problem, it doesn't matter which one you pick. You'll put 1 into the LCM. Then I have the x minus 7. There's 1 here. There's none here. So 1 goes into the LCM. And then this would be my final LCM. All right, so now let's get on to the actual meat and bones of this lesson is adding and subtracting rational expressions with unlike denominators. So now let's say we look at a problem like this. We have 3t plus 2 over t squared minus 2t minus 3 plus t plus 1 over t minus 3. All right, so unlike yesterday where the first thing we did was we looked at the denominators. They were the same. We knew that right away that was my denominator for my answer. Here, they're not, obviously. So the first thing I have to do is find the LCM, or the least common denominator, of my two denominators. So I'm going to literally do the exact same steps that I had just done in the previous problems with my two denominators. So I'm going to find the LCM of t squared minus 2t minus 3 and t minus 3. So that's what we do first. So I have to take this. This is a polynomial. I will factor it. This is going to factor out two numbers that multiply to get negative 3 and add to get negative 2 are going to be negative 3 and positive 1. So this will factor to be t minus 3, t plus 1. The t minus 3 doesn't factor, so we're just going to leave it as t minus 3. So now I look. I see 1t minus 3 here. I see 1t minus 3 here. It doesn't matter which one I pick. My LCM is going to be, or part of it will be, t minus 3. Then I move on to the next one. I see 1t plus 1 there. I see no t plus 1 in the denominator. Remember, we're looking specifically in the denominator here. I see no t plus 1 in the denominator here, so that goes into my LCM. So that means the LCM is t minus 3, t plus 1. That's the first step. Once we know what the LCM is, we know that my answer is going to have that as a denominator, meaning it's going to be t minus 3, t plus 1 in the denominator. I can write that right away. But the problem is, both of my denominators are not this, right? The first one is. The first one actually is this LCM here, but the second one is not. So my second step is I have to rewrite each rational expression with this common denominator. So this is what I have to do. I look at my LCM and I say, okay, with this LCM here, with this denominator, what's missing? Now, in this case, nothing is. T minus 3, t plus 1, t minus 3, t plus 1. They're exactly the same. So this first fraction will not change. This first fraction, I'm just going to rewrite exactly as is, but I'm going to rewrite the denominator as this just to make it easier for me to understand. So the top is going to stay as 3t plus 2 and the denominator is going to be t minus 3, t plus 1. Again, remember, we didn't change this denominator at all. We just rewrote it in its factored form. But now I look at the second fraction here, a rational expression. The LCM is t minus 3, t plus 1. This denominator is just t minus 3. What's missing? Well, obviously the t plus 1 is missing. So what I'm going to do is I am going to multiply the numerator and the denominator by t plus 1. It's the same as when you have a fraction and you're trying to get a common denominator. You have to multiply both top and bottom by the same number. That's what we're doing here. We are making this denominator t minus 3, t plus 1. That's what we want to do. But I can't just change it without doing the same thing on bottom and on top. So now, on top, t plus 1 times t plus 1, I actually have to multiply that through. So I'm going to double distribute here. T times t, t squared. T times 1, t. 1 times t, t. 1 times 1, 1. What I can do is I can change this t plus t. I can combine those to be a 2t. And now I have my new second denominator, or second fraction. Now I can work with this exactly as if it was a problem that we had in the previous lesson. Now that the denominators are the same, that's going to be my common denominator. I'm going to take my numerators and I'm going to add them together. So I'm going to have 3t plus 2 plus, because of the plus in the middle, t squared plus 2t plus 1. And now I just combine any like terms that I may see. I'm going to start with the t squared because it has the highest degree. But there's only a t squared, so that's going to go first, t squared. Then I see a 3t and a 2t. 3t plus 2t is 5t. Then I see a 2 and a 1. 2 plus 1 is 3. My denominator is going to stay t minus 3, t plus 1. The last step that you should always do after you've combined everything up top and added and everything like that, see if you can simplify. And what I mean by simplify is, can this top trinomial be factored? Can I cancel after I factor? Well, in the case of this problem, it can't be, because I would have to look for two numbers that multiply to get 3 and add to get 5, and that just can't happen. The only numbers that multiply to get 3 are 3 and 1. 3 times 1 is 3. 3 plus 1 is not 5. So this top one can't factor. So this is going to be my final answer for this problem. But again, that will not be the case in every problem. There will be problems where this top can be factored again, and maybe it factors into something that has a t minus 3, and you get to cancel those t minus 3s. So always be cautious. Always, last step, see if you can simplify again. Okay, but this is the process that we have to take if we don't have common denominators. First, find the least common denominator, or the LCM of the denominators. Then, whatever's missing, multiply both the top and bottom to make the denominator the LCM. Then I can add the numerators or subtract whatever the sign is, and then simplify. So 4 steps here. All right, so here are 2 more problems. I would like you to try these on your own. Again, take 5 minutes, pause the video, try them. When we unpause, we'll see all the work and the answers shown, and hopefully we get them correct. Again, be careful. Our denominators are not the same in either of them, so make sure that you do the exact steps that we talked about before. Find the LCM, multiply, add, and then simplify. All right, so here are our 2 answers. For the first one, the LCM between the denominators. You have a d and a d squared. So obviously d is just d. D squared is d times d. So there's 2 d's and d squared, so the LCM is d squared, which means that you are missing a d in the first one. So you will multiply both the top and the bottom by d. D times 4d squared will give us 4d to the third. D times d will be d squared. The second one you don't need to multiply anything by because we already have the LCM in the denominator. So now we're left with 4d to the third over d squared plus d plus 2 over d squared. Same denominator, that's my denominator in the answer. I add numerators. 4d to the third can't combine with anything, so it's 4d to the third. Plus d plus 2, and I can't simplify the numerator either, so this is my final answer. For the second one, here we have a monomial, here we have a binomial. So you have to remember, a monomial can't be split up any more than it already is, meaning I have to look at its prime factorization. But the prime factorization of b is just b. So b is going to be in the LCM because this is a binomial or a polynomial, which also can't be factored. So I also have to have the b plus 1 in the LCM. So my LCM is b times b plus 1. So if I look at the first one, I have the b, but I'm missing the b plus 1. So I have to multiply both top and bottom of the first fraction by b plus 1. In the second one, I'm missing the b. So I have to multiply both top and bottom by b. In the first one, when I double distribute the top, b times b is b squared. B times 3 is 3b. 1 times b is b. 3b plus b is 4b. And then 1 times 3 is 3. B times b plus 1, I can just leave as b times b plus 1. In the second one, I have to distribute the b. B times b is b squared. B times 5 is 5b. And then the bottom can stay as b times b plus 1. Now I get to add b squared plus b squared. That's going to be 2b squared. 4b plus negative 5b. That's going to give me a negative 1b, or just negative b. And then 3 plus nothing is just 3. My numerator cannot be simplified, so this is just going to be my final answer. Now, the good thing about subtraction, I know we haven't done a subtraction problem, but subtraction is exactly the same. The steps don't change. The only thing that's different is instead of adding your two numerators after you do all of this stuff, you're going to subtract them, just like we did in the previous lesson. So that's a good thing. Nothing really changes too much. You're just subtracting instead of adding.